The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Hello and welcome back to Dave and Nick's Shiny Side Out, show number 501. Why 500 doesn't really sound very good, does it? I'm waiting for 511. That's going to be cool. But 501, here we are, 501. We're going to talk about the hypothesis. We talked about a whole bunch of stuff just in the first hour, but this is the hypothesis. The hypothesis, we had 3 hours last week. we got through the first 2 pages almost of our show notes. So let me begin again.
It'll be with us until show 600.
Or possibly, because look, every 100 shows it expands significantly. Right now it's sitting at 95 pages. But we did have a bit of reminiscence last week. We went through some of the show topics that really form part of the wider show cycle. Some of the guests, which were fantastic, of course. Hopefully we can welcome a few more guests very soon as well. We will break whatever show cycle we're in in order to welcome our guests, of course. But let's get started down the rabbit hole. I'll go through it very quickly, and then we need to look at why we die, and that's really very interesting because there's no clear answer to that, believe it or not. Now, as we go down the rabbit hole, be aware, please, that all of this is a hypothesis. Moving into theory territory more now that we've spent so much time on it. Now, this is not just hard facts coming at you. Some is conjecture, and there's certainly some leaps. Some intuition, some intuitive leaps, as it were, some epiphanies even. Nonetheless, here it is. It's our drawing of the bowl, and we hope you enjoy the ride. First things first. What I'm about to read to you was written about 9 years ago, right? From today. Today's, it's the 24th of October, 2021. Firstly, there exists a power construct, a box, if you will, in which we all live. We're all indoctrinated early on to live within that box. This box is not of our choosing, yet most of us spend living their lives in that box. Most of us never know it. Secondly, the box is set up to be self-perpetuating. Thirdly, agencies within the box have become privy of its existence and exploited the nature of the box for their own purposes. 4. There is no physical escape from the box. There is no out as perceived within our 4-dimensional existence. 5. Reincarnation ensures that we always return to the box, most without any knowledge of our former lives, and I emphasize most, not all. 6. Everything within the box, which we deem good and right, as it enables us to live in the box, is in fact the exact opposite. 7. This knowledge is the most dangerous knowledge, and in the past, most who purported to know it or were suspected of knowing were persecuted and killed. It was knowledge handed from master to disciple and never written down. 8. The knowledge at this point in time is slowly seeping into the general population, ever so slowly. 9. We seem to be approaching critical mass, a rapture-like event potentially, which would free us from the box and which we call the awareness cascade. 10. The best way to stop this awareness cascade is mass destruction and mass death, as it has happened in the past. 11. One must acknowledge the box before one can think of planning an escape. And I want to re-emphasize here, this was written 9 years ago. Mm-hmm. What we have seen unfold, and by the way, it's Mackie reading, Flippy, just in case you find it hard to. I find it. I don't think we sound alike at all, but I could be wrong.
That's true.
Having said all of this, so the awareness cascade was meant to happen in 2020. That's when our algorithm pointed out to the magic number 7.76 billion would actually happen. It did happen, but then the pandemic happened, and everything didn't happen, including, unbeknownst to us, an event that was being undertaken by the Aboriginal inhabitants of Australia at Uluru, which was meant to be, in fact, an event that was meant to bring about such an awareness cascade, if you will.
And to everyone, that event T-boned us. We were completely unaware that it was going on.
Completely.
Yeah, until we were interviewing the Strongs.
Yes.
And they were saying, oh, there's this thing coming up. Really? When? Oh, that's exactly when our awareness cascade is supposed to happen.
And that, Dave, it really floored me in many ways. Now, because you think you're pretty smart, right? I mean, I'm talking about me now. We all think we're pretty smart and we know what's going on, right? And I got it all figured out. But then things happen and you realize, hang on, maybe we have something figured out, right? Maybe there's something there. Which is a little terrifying, because then the rest of it might be true as well. Okay, maybe not all of it, but from all indications and from everything I've seen, all the research I've done, that all the people we've talked to here, all the research Dave has done, it is almost inescapable that the hypothesis is scratching at the truth, if not digging deep in and revealing, certain parts of the truth, of a truth, if you will. This multi-dimensional universe. It is really something else when the things that you say will happen are happening, and they're then supported by cultures that have been around for 65,000 years. Oh yeah, that's going to happen.
Yeah. So I don't want to be the Mel Gibson Mickey getting dragged, kicking and screaming off into a police van, and going, which one was right?
Yeah.
Which theory was right? Which one? I don't want that to happen. So, yeah. And look, like I said, it took us by surprise, only to find out that the world's most continuously populated with the same peoples, the idea that this was the year of the event, how did they know in advance of this?
Yeah.
That's that we're still trying to find out.
Oh, they clearly listen to the Shiny Side Up. That's what happened.
That's what they. Yeah.
I'm kidding.
We are kidding.
It's a joke. That is a joke. How? I mean, this is what we talk about: the elder knowledge, ancient knowledge, knowledge has been passed down verbally, if you will, from generation to generation. Not written down, but told in stories. And I spend a lot of time. And we will talking about the dreaming and the dream time when we come to it. People always assume that this is an event in the past. Nothing could be further from the truth. The dreaming or the dream time is everywhere. It's happening right now. We are just separated from it by a gulf we can no longer bridge. There's an abyss between us and the dreaming. We can't get there. And this abyss is the black iron prison I'm talking about. We are here in this prison, and we can't get there. So if you talk to Aboriginal people or any First Nations people anywhere, really, they're not talking about a golden age sometime in the past, right? What they're talking about, no, it's right now, but we can't get there anymore. We just can't get there. It's always happening, but it's just maybe some of us can get there, but some of the dreamers, the shamans, who else, right? But most of us can't. But Dave, let's start with one of the fundamental questions of our existence, because this is important, right? Because we all do die, or most of us. Why do we die, Dave?
Well, you could have to put it down to the theories on aging. Now, no single theory on how and why people age is able to account for all aspects of aging, but most take one of two approaches. One, that humans are genetically programmed to age and die. And number two, the natural wear and tear causes aging and eventual death. Arguments in favor of genetic programming cite hormonal control and or limited cell division or reproduction as the mechanisms involved in the aging process. One hormonal approach focuses on the hypothalamus, at the base of the forebrain, which controls the production of growth hormones which influence growth and development. In the pituitary gland, that is, it is thought that possibly due to the action of a hormonal clock, the hypothalamus, either slows down normal production function or that it becomes more error prone with time, leading to physiological aging. Repeated experiments have shown that human cells grown in tissue culture in the laboratory will divide only about 50 times before they die. Exceptions are cancer cells, which have unlimited growth, and brain and muscle cells, which do not divide after birth. This suggests a genetic clock that limits how many times cells can divide. It is also thought, or it is thought, that as cell division decreases, as it does in older people, the functioning of the body also begins to slow down, resulting in aging and eventual death. The wear and tear theory of aging and death suggests that genes, the molecules that carry instructions for passing on specific traits from one generation to another, are altered by random mutations, or maybe changes in form, that accumulate over time, gradually leading to aging and disease. Environmental agents such as X-rays, ultraviolet radiation, and basically anything and not including, but everything above visible light is dangerous to human DNA. And so, I'll go back to the text. And chemical toxins can contribute to this mutation process. All cells have the ability to repair damaged DNA. Deoxyribonucleic acid, the molecular basis of heredity. Is that right? Yep. But when these repair mechanisms fail, mutations can accumulate. This failure is also thought to be a factor in the development of cancer. And now I know we're going to outline everything that wasn't mentioned in this piece.
Oh yeah.
Later on, I just want to park you there. Yeah.
So essentially, what they're saying is either our bodies are designed to die, so we've that built-in kill switch, or the death just happens because we wear out over time. Now, I think it's both in actual fact, but so we do have a kill switch. That's number one.
We do.
And number two, yes, we also suffer from natural wear and tear. And by wear and tear, I'm talking about the ingestions of chemicals that are not good for you necessarily, right? Coffee, alcohol, tobacco, etc., etc.
And environmental issues.
Completely, right? Radiation, etc., etc. So all of that can definitely harm you and cause your death, right? So let's say you're immortal for a second before we go into the mystery here. But let's say you are, right? Now, what does that mean, really? Okay, so immortality comes in many, many different forms. People have imagined it in many different ways. But the only form of immortality that would make sense, if the one that anybody really wanted, would be immortality, which leaves you in a fairly young and strong body, right? As well as a fairly young, or not young, but a strong mind. So you don't want to become senile and be in the body of a 20-year-old athlete. That's no good. So you want a mind that is whole and hale, and you want a body that is whole and hale. That's when immortality makes sense, right? So let's say that could be achieved, and how we can do that we'll get to in a little while. You can still die though. So you can stop. You can arrest the aging process, right? Telomere therapy, etc., etc. And by eating really well.
Yeah.
No. We're going to come to that. And eating really well, really looking after yourself, right? If you do all of those things, and you have the fountain of youth there handy as well, and what it won't stop is a rock falling on your head, or you're falling down a hole, or any other mishap that could end your life. That could still happen. So when we talk about immortality, we're not talking about superhero type people, right? We're talking about regular folks that just have figured out how to live a lot longer, right? It doesn't come with superpowers like invulnerability, right? Or anything like that. Not that we have come across it anyway, right? I'm not saying that these powers are not necessarily in existence. It is just that I haven't seen any evidence for it necessarily. Certainly, there's some interesting things out there, but invulnerability, I have not come across per se. Now, that gets us to the mystery, right? Now,
What is it?
This is the mystery. This is a quote I'm quoting here, right? So, from every tree in the garden did he grant them to eat, save but one. And that tree in the center of the garden was called the tree of life. And the snake said to Eve, eat of this fruit, and you will become as God and never die. Genesis 3:1. So I just want to spend 1 second on this, please. So it's really interesting. So in the Bible, it tells us, oh, we were cast out of paradise because Adam ate from the tree of knowledge, which he did. The snake, convinced Eve that, you should really, try it. It's a good apple. Apples are sweet. So Adam ate the apple, and all of a sudden he had understanding, right? So he had knowledge, and he was punished. But he wasn't punished for eating from the tree of knowledge. He was expelled from the Garden of Eden together with Eve, because God wanted to make sure that he didn't eat from the tree of life and become like God and never die. So have knowledge and life would have made Adam and Eve godlike. And that's why they were expelled. They were expelled so they couldn't eat from the tree of life. Just to be clear, right? Because a lot of people think, go on.
I think that whole description of the snake and the eating and the trees and the choices, and I think that it's all this is my personal opinion, that it is a complete misunderstanding of the actual verse that it was deciphered from. And I believe that if I had to line that up with an event, it would be that they were created not to have endless life, and that there's a time limit set, and it would have been the Anunnaki doing that through the Yagigi, right? That to me, about the choice in eating, to me would have been the choice of designing the human. But I'll park it.
No, but let's just spend 1 second on this. So a lot of cultures in the world have this legend of someone giving fire or knowledge to humans, right?
Yes.
I mean, Prometheus is probably the most famous of those, and severely punished they are for it as well, right? Now, Lucifer, which actually means bringer of light, was also punished for giving knowledge to the people. And this is why I said you might not like to listen to the show, because it will rattle your cage on a very fundamental and deep level, right? And remember, in war, the histories are always written by the victors.
That's right.
Okay.
Yeah.
So it seems that in some distant event in the past, the human race was created. Well, not this human race, a previous human race, potentially, for a very specific purpose. We'll get to that in due time. And they were a working race, right? That's what their purpose was. And they didn't need knowledge, certainly not immortality, as their creators had, practical immortality. So it seems that at some point, though, some god took pity on those humans and gave them knowledge and started teaching them. God knows what that means, right? But something happened that triggered this memory that we now have of Prometheus, of Lucifer, etc., right? And then there must have been another event which would have terrified the gods, where the humans they might have been in the works of gaining immortality for themselves, which was of course completely unacceptable, I'm sure, in their mind. And they were cast out, and I think that's where legends get mixed up. The story of the Tower of Babel, language confusion, all kinds of things. And before that could do any further damage, they were clearly expelled from whatever area they were in, so they could not gain any more knowledge and could not gain immortality. And there are many stories where humans were either granted immortality for extraordinary deeds, like Hercules, for example, right? Or they were denied immortality for their friends, as in Gilgamesh's example. So this is a very rich tapestry.
So which
Of
one
stories.
left with them? Which one left
Sorry?
to join them?
Well,
join
that's
gods?
the question. Oh, sorry, Hercules.
Yes.
He was allowed to. Yeah, he was allowed to. So extraordinary human beings are allowed to join the world of the immortals. Also helped that one of his parents, Zeus, happened to be his father, so that helped.
It's who you know.
It's who you know. Now, but just be very clear here. There's a lot of knowledge in ancient times coming to us in the form of myth and legend, and completely, not necessarily just distorted, but certainly simplified, right? And we have to get to the core of the truth. What is the story trying to tell us? What is the story trying to tell us? Now, okay, so this is Genesis, right? In 1786, average life expectancy was 24 years. 24. 100 years later, in 1886, it doubled to 48 years. Right now, and I think this has actually been superseded, a newborn can expect to live an average of 76 years. With recent discoveries in biology, and many scientists predict that life expectancy will continue to triple digits. In fact, if they're correct, humans shouldn't have to die at all in the future.
Yeah.
At all.
Mm-hmm.
Over half of the baby boomers in America are going to see their 100th birthday and beyond in excellent health. Well, not with the SARS-CoV-2,
to some extent.
Yeah. But we're looking at lifespans for the baby boomers and the generation after the baby boomers to 120 to 150 years of age. And that's coming from Dr. Ronald Klutz of the American Academy of Anti-Aging. This is Dr. Klutz again here. Anti-aging medicine is not about stretching out the last years of life. It's about stretching out the middle years of life and actually compressing those last few years of life so that diseases of aging happen very, very late in the life cycle, just before death, or don't happen at all. That's what I mean by, if you wanted to live for a long time, Dave, you don't want to live in a wheelchair. You don't want to live in an iron lung. That's just torture. I mean, why? You want to have a body that's strong and healthy, and you want to have a mind that is strong and healthy. Now,
well,
the
Mickey,
cause of
I'm going to put it this way: if we only lived to 24, we would never have known about menopause.
Bingo, 100%, 100%. Now think about that for a second. So, and we're going to actually discuss.
That's the Neo moment. Do you think that's air you're breathing?
Yeah, that's right. You think it's air you breathe? it's fantastic. I love that scene. But see, we're gonna discuss this in some more detail later, because we also believe that our lives are cut short without us ever fully experiencing everything we could be. That might sound a little cryptic right now. Just bear with us.
It'll make sense later.
Yeah, it will. Now, immortality has silently been revealing itself to scientists like Dr. John Langmore of the University of Michigan's Department of Biology. Dr. Langmore and his group looked inside human cells at the very essence of human life, the DNA molecule. Specifically, Dr. Langmore looked at the tips of the DNA molecule, a previously overlooked part of the double helix molecule that contain a kind of chain of repeating pairs of enzymes called telomeres. These molecular chains have often been compared to the blank leaders on film and recording tape. Indeed, telomeres seem to perform a similar function, Dave.
Yeah. So, what exactly are telomeres? Telomeres are special, essential DNA sequences at both ends of each chromosome. Each time chromosomes replicate, a small amount of the DNA at both ends is lost by an uncertain mechanism. Because human telomeres shorten at a much faster rate than many lower organisms, we speculate that this telomere shortening probably has a beneficial effect for humans, namely mortality. So when they say beneficial, if you consider beneficial actually meaning that you'll reach a certain age and then die, well, sure, why not? The telomere hypothesis of aging postulates that as the telomeres naturally shorten during the lifetime of an individual, a signal or set of signals is given to the cells to cause the cells to cease growing. What's that? Senescence? Yeah.
Senescence.
Senescence. At birth, human telomeres are about 10,000 base pairs long, but by 100 years of age, this has been reduced to about 5,000 base pairs. And look, the telomeres, once they get to a certain length, they're no longer able to, they call it junk DNA, which is there to be expendable through the replication process. And I think that, to be honest, that is the key to our maybe the fountain of youth in humans, is to keep those going. So there was a Nobel Prize winning discovery made right there. So telomerase is actually an enzyme, a catalytic protein that is able to arrest or reverse this shortening process, which means it can grow back your telomeres. Normally, telomerase is only used to increase the length of telomeres during the formation of sperm or perhaps eggs, thus ensuring that our offspring inherit long, young telomeres to propagate their species. During the replication process of the spiral DNA molecule must split in half and reassemble a copy of itself, protecting the vital DNA molecule from being copied without a sync. Copied out of sync. So that's how they sync up. The telomeres provide a kind of buffer zone where misalignments, which are inevitable, will not result in any of the important DNA code being lost. Perhaps the best analogy is to compare the telomeres to a white margin surrounding an important typewritten document. In this analogy, the printed text is the vital DNA code, while the white space is the blank telomeres. Now, if you were to photocopy that on a photocopier 100 times, there you go. That's what happens. Mm-hmm. You might lose that. It's sacrificial. So each time the paper is subject to errors of alignment, and these errors accumulate after enough copying, it is probable that the white space will diminish and some of the actual text will not be copied or be cut off. That's what happens inside our cells, and it is the reason we get old and die. As cells get older, it is under attack by oxides and free radicals in the body and the environment. We survive as living beings because our cells have the ability to duplicate and replicate themselves before being killed by these natural causes. Each time our cells divide, the DNA molecule makes a new copy of itself, but the procedure is very complex and not perfect. Usually a small portion of the DNA molecule is lost, misaligned, or copied. Since errors are more frequent on the ends of the DNA molecule, this area, the telomere, does not contain any important DNA information, and the effect is insignificant. Meki.
Telomeres are indeed programmed to die. Scientists observe that the length of telomere chains becomes shorter as we grow older. Sense? Eventually, the telomeres become so short that cell replication produces lethal errors or missing pieces in the DNA sequence, ending the cell's ability to repair itself, or replace itself, so it can no longer divide properly. This point, when the cell has lost vital DNA code and cannot reproduce, is called the Hayflick Limit. Hayflick, Hayflick Limit. It's the measure of how many times a cell can copy itself before it dies. Some cells in our body have a very high Hayflick limit. Cells that line the inside of your mouth and intestines, for example, are constantly being worn away and replaced. Indeed, these cells appear to have the ability to regrow telomeres even in aged bodies. Scientists were curious why some cells shut down telomere growth with age and some do not. Dr. Langmore, whom we just met, used physical, biochemical, and genetic techniques to study the structure and function of telomeres. His group developed a cell-free system to reconstitute functional model telomeres using synthetic DNA, and studied the mechanism by which telomeres normally stabilize chromosomes and how shortening of the telomeres could cause instability. The protein factors responsible for stabilizing the ends of chromosomes are being identified, cloned, and studied. electron microscopy is used to directly visualize the structure of the model telomeres. Dr. Langmore's group used new enzymatic assays to determine the structure of telomere DNA in normal and abnormal cells grown in vivo and in vitro in order to address specific hypotheses about the role of telomeres in aging and cancer. Scientists have discovered an important enzyme that can turn the telomere production of the DNA molecule on and off. It's called telomerase, or as Dave said, telomerase. Not surprisingly, it seems as we grow older, the amount of telomerase in our cells decreases, Dave.
Mm. And now this is talking about something that was a recent discovery making through our research, and it's the cancer problem. Usually, if a cell makes an error in copying itself, the error will prevent the cell from duplicating itself in the future, so the mistake is limited. But with cancer cells with errors somehow turn on the production of telomerase and make the mutant cell immortal. Now, aberrant cells that can reproduce unchecked and outlive normal cells is what that turns into. This is the process that creates tumors. Since we have all the mutant precancerous cells in our bodies already, nature has decided to shut off the telomerase as we age, thus preventing these mutant cells from growing telomeres. It's a kind of programmed death, a trade-off, if you will, to reproduce or reduce the lifespan in order to save us from being riddled with tumors. And of course, this is not specifically Meki and I, our opinion here, but we'll get to that. Nevertheless, some precancerous cells manage to reactivate their telomeres via telomerase, and this has caused the research to focus more on blocking telomere production rather than trying to extend it. Anti-cancer researchers believe that by introducing a molecule to block this groove, the telomerase would become unable to attach itself to the DNA and thereby limit the length of the telomere production. And of course, it doesn't actually attach itself, it's present. But anyway, then I'll be quiet. While this work holds hope for stopping tumor cells from reproducing forever, it does do little to extend healthy cells from being rejuvenated. However, the molecular blocker could specifically target only cancerous cells without blocking telomerase activity in healthier cells. It could be a step forward towards human life extension, and if and when a pharmaceutical could be developed that activates telomerase in the human body. I'm just going to put this out there. There is TA65.
Yeah, 100% correct. So, but before I go into the next point here, which sort of is refuting some of the previous text, which is taken, obviously from a scientific magazine. Just be clear that we believe very strongly that whatever the mechanism is that has been deployed in the past, and I'm talking about the dim and distant past, immortality, functional immortality exists, right? We know it because it has been with us in our stories and our legends and myths and fairy tales and religions, etc., from the beginning of time.
But there's a shrimp and a jellyfish, isn't there, Mackie, already?
Yes. So they're actually immortal creatures. Yes, that's you're right. You're 100% correct.
Yeah.
So they do exist. But I also believe that we have humans, I guess we should call them, entities, that are in fact immortal, right? And they have been with us for a very long time indeed. And they have now become institutionalized in this particular prison box that we find ourselves in, and they're instrumental in some of our dooms.
Oh, Mackie, if you couldn't escape here because you lived forever,
yes,
what would you do? I mean, how would you behave? You'd behave just like them.
Exactly. So they somehow found immortality, and they didn't get the insight that this is actually a prison. But now they've become so used to it. So if you and this is actually human psychology. if you've been in prison for 40, 50, 60 years, for the majority of your life, let's call it, okay, and you're released, most people can't cope with that because you are used to a certain way of life, and that's called, institutionalization of the person. They can no longer function in society where their choices are free. I can do whatever I want. Well, I need someone to tell me what to do. I need my order. I need my schedule. But you don't have it because you're not in prison anymore, right? So people don't do well necessarily, and some people commit crimes just so they can go back to prison.
Yeah, that's true.
So especially older prisoners, people that are released in their 60s, 70s, or even 80s, which I think is a cruelty. But nonetheless, there it is, right? It's a thing. And imagine you're stuck here for thousands of years, and you have never had the, I guess it's in some ways it's a relief to be reborn without memories, because you can sort of start from scratch, and the damage isn't there as much as in these other people. Now, let's go back to the cancer problem, though, please, just for a second. Now, this is my opinion, and Dave can jump on board here if he likes to, but the cancer problem, as stated above, in my opinion, represents a fallacious argument. First of all, nature decides nothing, right? Nature is not a person. Nature is not an entity. Nature is just all the stuff around us that we are part of and live in. Okay, so nature is not a personified person, being, thing. It's not. So nature can't decide anything. So the text above said, well, nature decides to do this and that. No, nature decided nothing. Right? If we are truly an atheist scientist, right, that believes in evolution, there's nobody's deciding anything. Things just happen. It's a mutation. Most mutations, by definition, are bad mutations. Okay, but there is no guiding principle, according to scientists, atheist scientists. There isn't. It just doesn't exist. So I hate to see it. Whenever I see it, it really bothers me. Nature has decided to shut off telomerase as we age, the text stated. Anyway, so nature decides nothing, unless, of course, we have now moved into a creationist pagan parallel universe, in which it's perfectly okay to say that somebody has decided something, God or creator or power or the great spaghetti monster in the sky or whatever. Okay, so nature is an abstraction we use to describe biological, chemical, and physiological processes.
I love the leader.
Okay, I love the leader. You cannot have it both ways. Either there is a creative force that makes decisions, or there's not. Okay. In essence, right? So that's so. But the next point.
Oh, I want to interject.
Yeah, go.
Look, it's the argument against activating everybody's telomerase, so that our telomeres return to their, true and rightful size, and that we're all immortal. The failed argument is that we'll all just get to cancer and die, because the ability for our cells to turn telomerase on and, the ability for our cells to replicate, even given a mutation, and just, go on forever and become a malignant growth. That argument is kind of flawed, because the only reason the cell refuses to replicate is because it's mutated so wrongly, and that there is a mechanism, probably like, is it HPV, the cancerous virus causing, like, it's a virus that causes cancer in the uterus. Mickey?
Yeah,
Right?
the haplovirus. Yes.
Yeah, that's right. Yeah, the HPV. I was right.
Yep.
So HPV affects a cell by doing an action, and the action is to make it mutate and to turn on telomerase. So that's really important to know that that's how that happens. Simply turning telomerase on doesn't cause cancer. There's a distinction here that I think is very important. If our telomeres are all the right length, the mutations are reduced, unless, of course, we have environmental factors.
Yes.
So, like, we encounter a virus, or we're killed by a wooden stake or a silver bullet, just being a bit Hollywood. So that is really important to delineate the difference between those two things. And they've, in that text above that I read out, they kind of wanted to mash it together and make it really confusing for someone to understand. Oh, it's going to cause cancer then. And that opinion is everybody on the internet who's read that paper and believes that's the outcome that the paper is suggesting, and in fact it doesn't.
Yeah, Dave made a very good point. I completely agree with that. Right? It is a fallacy to say any of these things, because if the telomeres were to stay at the length at the ideal optimal length,
Mm-hmm.
then the simple fact is that cell degradation would not happen. We would not be aging. So if you had telomerase on all the time,
Mm-hmm.
the telomeres would be protected and we wouldn't age. Full stop. Could we still get cancer? Sure. Radiation, like
Mm-hmm.
Dave said, toxic chemicals, blah blah blah,
Mm-hmm.
whatever, lifestyle choices, right? Sure you could. But the point is, the cancerous cells, they switch the telomerase on anyway.
That's
So
right.
our body switches it off at a certain age. For most parts of our body, it's switched off.
That's right.
Right? Done. It's over. Done. Too bad. It's off. Now the copying process then becomes less and less accurate as we move on, and causing cells to mutate, causing cancer, which in turn turns telomerase back on to protect itself.
Mm-hmm.
That's the process flow here. There's no other process flow. This is what happens. Good cells that are good, right? Let's assume no radiation, no harmful environmental
factors. Yeah.
Yeah. And no predisposition to cancer from a DNA perspective either.
Mm-hmm.
Let's assume that, right? So here we go. Healthy cell, telomerase is on. The enzyme is on. It's protecting our telomeres. They stay nice and long at 10,000 base pairs. Beautiful. Forever.
You could visit it in a million years and it'd still be the same cell.
Bingo. Right? No, we turn it off. Let's turn it off. So we're turning it off. So the body turns off the telomerase, the enzyme that protects. Okay. And then after a certain time, the base pairs become shorter and shorter, and the copying process introduces more and more errors into your cells.
Mm-hmm.
Right? That's what's happened. That's actually life, right? And then when the copying errors become so bad that the cell can't function anymore, right? It mutates, for argument's sake, and turns into a tumor, right? Into a tumorous growth, and that growth, through some mechanism which we don't fully understand yet, turns on the enzyme again to protect itself and its telomeres in the copying process. So for all intents and purposes, a cancer cell is immortal, as we have learned. So it will copy itself quite happily forever.
So a cell that has run out of telomeres and is now so poorly corrupted or badly corrupted, depending on your definition, then it is instructed not to replicate again. Yeah, that's it does state that, and that is a thing. It's a protection mechanism. But while we're getting to that point, we start to visually age, and these are inherent. This is Cinnabar's inherent system, and these are inherent in that lifespan process of the telomere being of a consistent length enough to preserve the data integrity of the DNA. That's all we're looking at. And when you put it so simply as that, well, just keep those telomeres going, right?
Yeah.
Keep them going.
So
then we can live forever.
So the fact that nature has decided to shut
Flea Kelly said, a cell that runs out of telomeres is like an Alec Baldwin gun that runs out of bullets.
I think it's too soon.
Too soon.
I think so. No, but see, so the scientists say that now nature has decided to shut off the telomerase as we age, thus preventing these mutant cells from growing telomeres. So that's actually complete nonsense. That statement is actually wrong. It's wrong. Now we all have mutant precancerous cells in our bodies. Yes. But as soon as they turn cancerous, they turn the telomerase back on. Okay, so this turning off has no effect except that it makes the copying process imperfect, rendering us more likely to have cancerous cells in the first place.
Mm-hmm.
It is. Do you understand? I mean, I hope everybody understands this crazy backwards. I mean, maybe I got it all wrong. I'm happy to debate this or to be educated by any researcher in oncology. Tell me where my understanding is wrong here. Because this is a chicken and egg thing, except that you understand now what the chicken and egg are. If we turn telomerase off, telomeres will be damaged or shorter, right? And our cells in turn will be damaged. That's a thing that will happen. If you leave telomerase on, if you leave it on, chances are that our telomeres are protected and our copying process will go on much better than without the long telomeres.
The integrity is withheld, Mickey.
Yeah.
It's
so
upheld, not withheld, upheld.
Yeah, and I've done a lot of reading here on this, and I've got books on this stuff now, and I just don't understand how this can still be an argument in the medical community. Now, I understand why people in cancer research want to shut off telomerase. I get it, of course, because if you can shut it off in a cancer cell, that means you can kill the cancer effectively, right? I understand that research, but shouldn't we be looking at the other end of the process line here, where the telomerase is shut off in the first place? Should we turn it back on in young people, or leave it turned on, so that the telomeres don't get shortened, right? Anyway, that's my opinion. So in essence, what we've just shared with you means that we have built, that we have a built-in kill switch. Why do we have a built-in kill switch? Now, we do want to share some of the latest news on telomere and telomerase research, Dave.
Yeah, so this is a hidden secret of immortality, enzyme telomerase. Can we stay young forever, or even recapture lost youth? This was dated the February 27th, 2018. Remember, that's kind of a year and a bit before the COVID thing. Arizona State University. Can we stay young forever or recapture lost youth? Research from the laboratory of Professor Julian Chen in the School of Molecular Sciences at Arizona State University recently uncovered a crucial step in the telomerase enzyme catalytic cycle. The catalytic cycle determines the ability of the human telomerase enzyme to synthesize DNA repeats, like DNA segments of the 6 nucleotides onto chromosome ends, and so afford immortality in cells. Understanding the underlying mechanism of the telomerase action offers new avenues towards effective anti-agent. There you go. Oh boy, anti-aging therapeutics.
Yes, Mr. Smith.
Yes, that's what I wanted to do. Gotta watch out for those agents. They'll pop up anywhere, even in the word aging. Typical human cells are mortal and cannot forever renew themselves, as demonstrated by Leonard Hayflick a half-century ago. Human cells have a limited replication or replicative lifespan, with older cells reaching this limit sooner than younger cells. This Hayflick limit of cellular lifespan is directly related to the number of unique DNA repeats found at the end of the genetic material bearing chromosomes. These DNA repeats are part of the protective capping structures termed telomeres, which safeguard the ends of chromosomes from unwanted or unwarranted DNA rearrangements that destabilize the genome. Some might think of them as those little plastic tips on your shoelaces. They keep the shoelace from unraveling, and that's very, very similar. Not that you've got to think the DNA unravels; it doesn't align very well, and therefore you get errors. Each time the cell divides, the telomeric DNA shrinks and will eventually fail to secure chromosome ends. This continuous reduction of telomere length functions as a molecular clock in such that counts down to the end of cell growth. The diminished ability for cells to grow is strongly associated with the aging process, with the reduced cell population directly contributing to weakness, illness, and organ failure. Becky.
The fountain of youth at a molecular level. Counteracting the telomere shrinking process is the enzyme telomerase that uniquely holds the key to delaying or even reversing the cellular aging process. Telomerase offsets cellular aging by lengthening the telomeres, adding back lost DNA repeats to add time onto the molecular clock countdown, effectively extending the lifespan of the cell and therefore the organism. Telomerase lengthens telomeres by repeatedly synthesizing very short DNA repeats of 6 nucleotides, the building blocks of DNA, with the sequence GGTTAG onto the chromosome ends from an RNA template located within the enzyme itself. However, the activity of the telomerase enzyme is insufficient to completely restore the lost telomeric DNA repeats nor to stop cellular aging. The gradual shrinking of telomeres negatively affects the replicative capacity of human adult stem cells, the cells that restore damaged tissues and or replenish aging organs in our bodies. The activity of telomerase in adult stem cells merely slows down the countdown of the molecular clock and does not completely immortalize these cells. Therefore, adult stem cells become exhausted in aged individuals due to telomere length shortening that results in increased healing times and organ tissue degradation from inadequate cell populations. Again, okay, adult stem cells become exhausted, aged individuals. Okay, the activity of telomerase in adult stem cells merely slows down the countdown. Okay, so anyway, now which brings us to Dave.
Tapping the full potential of telomerase. Understanding the regulation and limitation of the telomerase enzyme holds the promise of reversing telomere shortening and cellular aging with the potential to extend human lifespan and improve the health and wellness of elderly individuals. Research from the laboratory of Chen and his colleagues, Yinan Chen, Joshua Podlewski, and Jianyugan Logaswaran. Look, I just pronounced those like I read them, Mickey. Recently uncovered a crucial step in the telomerase catalytic cycle that limits the ability of telomerase to synthesize telomeric DNA repeats onto chromosome ends. Here's a quote. Telomerase has a built-in braking system to ensure precise synthesis of correct telomeric DNA repeats. This safeguard brake, however, also limits the overall activity of the telomerase enzyme, said Professor Chen. Continuing, finding a way to properly release the brakes on the telomerase enzyme has the potential to restore the lost telomere length of adult stem cells and to even reverse cellular aging itself. That's very critical to know that. The intrinsic brake of telomerase refers to a pause signal encoded with the RNA template to telomerase itself for the enzyme to stop DNA synthesis at the end of the sequence of GGTTAG. When telomerase restarts DNA synthesis for the next DNA repeat, this pause signal is still active and limits DNA synthesis. Moreover, the revelation of the braking system finally solves the decades-old mystery of why a single specific nucleotide stimulates telomerase activity by specifically targeting the pause signal that prevents restarting DNA repeat synthesis. Telomerase enzymatic function can be supercharged, well, I like superchargers on a car, to better stave off telomere length reduction, with the potential to rejuvenate aging human adult stem cells. Human diseases that include dyskeratosis congenita, aplastic anemia, and idiopathic pulmonary fibrosis have been genetically linked to mutations that negatively affect telomerase activity and or accelerate the loss of telomere length. This accelerated telomere shortening closely resembles premature aging with increased organ deterioration and a shortened lifespan from critically insufficient cell populations. Increasing telomerase activity is the seemingly most promising means of treating these diseases. While increased telomerase activity could bring youth to aging cells, and cure premature aging-like diseases, too much of a good thing can be damaging for the individual. Oh, we made them 8 years old again. Why am I 8? Have you revoked my healthcare card? Right. What happens to my 401k? You know, if I'm now 8, and all of your stuff gets signed over to someone to be responsible for your decisions. Could you have been previously 80 and held all of those intact and then became 8 again? And I'm making a joke here, but yeah, crazy. You know, we can just ask Britney Spears what it's like to have a conservatorship. Yeah. Too soon. Mecky, there's the music already.
There's the music. Don't go anywhere. Jerbe is coming up with an awesome roundtable. And next week, it's going to be more of this, guys. How good is that?
Pretty good. And this has been David Meckie's Shiny State Art, show number 501. Take care, guys. And until next time.